Depending upon the nature of the attacking reagent, the addition reactions can be classified into following categories. 1. Nucleophilic addition reactions. The addition reactions initiated by the attack of nucleophiles are termed as nucleophilic addition reactions. These reactions are very common in the case of carbonyl compounds. In a carbonyl compound, there exists a double bond between carbon and oxygen atom. That is, a carbon is connected to oxygen by means of a double bond. Due to the electromeric effect, the electrons forming carbon-oxygen bond, the pi bond get transferred to oxygen. Of this double bond, one is pi and the other one is sigma. These pi bond electrons are transferred to this oxygen. Thereby, oxygen gets a negative charge and carbon gets a positive charge, because oxygen is more electronegative than carbon. Thus, the carbon atom of the carbon double bond oxygen develops a positive charge. That this is the positive charge because of the shifting of electron, and becomes susceptible to the nucleophilic attack. For example, addition of hydrogen cyanide to acetone takes place as follows. This is acetone molecule, that is CH3 double bond oxygen. One is a pi bond, the other one is a sigma bond. From the pi bond, both the electrons are transferred to oxygen. As a result, in presence of HCN, what happens is that carbon gets a positive charge and oxygen gets a negative charge. The Cn ions, that is Cn minus, comes to this positive carbon atom and form a bond like this CCN. Now next is oxygen, which is negative, which is a fast reaction. That is the H plus from the HCN. H plus attacks this oxygen minus and forms an OH bond. This is the chemical reaction, or the mechanism takes place. Electrophilic addition reaction. The addition reaction initiated by the attack of an electrophile are called electrophilic addition reaction. These reactions are usually shown by alkenes and alkynes. For example, addition of bromine to ethylene is a reaction of this type. It occurs through the following mechanism. Ethylene, there is a pi bond and a sigma bond. The pi electrons are transferred to one of the CH2, making it CH2 minus and the other CH2 plus. This bromine molecule undergo heterolytic fission and forms Br plus and Br minus. Br minus attacks the Br plus attacks the CH2 minus and forms CH2Br minus and plus. That compound is having a positive charge. That positive charge is neutralized by this Br minus and forms CH2Br, known as 1,2-dibromoethane.